Okay, I want to do this quick little bit of review. So let's take a look at a couple problems. This should be easy stuff for you guys, but I want to make sure you're just looking at this the right way. So take 15 seconds and look at that and tell me how would you factor that. And don't say it out loud, raise hands. Now I'd like everybody to kind of, here's the goal. Everybody needs to contribute something today in class. Okay, so that's the goal. Jake, you get the ball rolling here. What are you going to do?
Negative 7x.
There you go, good. So we're factoring out a negative 7x, leaving us with
X plus 2.
very good. Okay, so the key is we're always, now, and notice all three of these examples, you can't see the bottom one, but they're all examples of factoring quadratics that are binomials. What's a binomial? Two terms, okay, two terms. So these, when you're factoring binomials, they're easy, right? They're easier than trinomials, but you just got to make sure there's two routes you can go. You always want to see if you can factor out a GCF first, and if it's a quadratic binomial and both terms have an x in it, that's it. That's all you got to do, right? Factor out a greatest common factor that's going to include an x, and then you're going to get some other factor that's got an x in it, and you're done, right? Those are easy. Okay, what about this one? Somebody else. What do you got, Callie? Factor out a 2 first. Good. So first step would be we're going to take out a 2, which leaves us with what?
X squared plus, minus.
Okay, we done? Okay, what else could we do there? Difference of squares. Good. It's going to be x squared minus 8 squared, right?
Yep.
So then this would split up by the difference of squares pattern into x plus 8 times x minus 8, because 64 is just 8 squared. Okay, makes sense? So what's something you want to, what's kind of the flag you want to see on this that's telling you, okay, try difference of squares. If I've got a factor that's got an x squared term, and it could have a coefficient, but it's got an x squared term minus a number, a term with no x in it, the only pattern it could fit is difference of squares. Is it guaranteed to fit difference of squares? No, it's not. But it might, so you want to check. Okay? How about the bottom one? What are you going to do? Factor out a 3. Okay, so I take out a 3, and I'm going to make this a 9. I'm going to change this around a little bit. You still factor out a 3 though, right? Actually, I'm going to make that an 8. Let's see, I want to make that a 27. So I'm making this one a little tougher, right? You factor out a 3 still, and I'm going to get 9x squared. No, 9 isn't going to 75. So 9x squared plus 25. Okay, now what? Then I'm done. Good. So it's, what if that were a minus? Then I'd have a 3x quantity squared minus a 5 squared, and I'd do difference of squares, right?
Yeah.
But because it's a plus, we're done. There is no sum of squares pattern. So we're done. Good. All right. From day before yesterday? No, 2 days ago. 2 days before yesterday, so Monday, I guess. I don't know. Something like that. We started looking at solving by completing the square. Easy stuff for you guys, though, because we've already done this, right? It's essentially the same steps we did before, only instead of transforming an equation into vertex form, now we're solving an equation. Okay, but what was our strategy here? So like on this guy here, what did we say we wanted to do? Well, we wanted to get the x squared plus bx by itself on one side, just like we did last unit, right? And so that meant we added the 56 to the, or subtracted 56 to the other side. And then we were just going to complete the square on the left side, right? So we're going to add to both sides half of b squared, which means we're going to get a perfect square trinomial on the left, where the magic numbers are just going to be half of b and half of b, right? Okay, and then from there, now how can we do that? Well, look what that process did for us. We started off with a quadratic trinomial where I had both x squareds and x's, right? So I'm not able to isolate x. I've got to do something more complicated like factor. Okay, but what if it doesn't factor? Maybe it doesn't, right? So that's an option we don't have anymore. by completing the square, how does the equation look different and easier now? Yeah, good, right? Because now we end up with a single x that we can point to, so we can reverse order of operations and isolate it. So that's the strategy behind completing the square. Okay, let's try a couple more of those just for practice. So what about this one? What am I going to do? Okay, first of all, good. We want to divide by 2, right? Remember, I'm free to divide both sides of an equation by a number. I just can't divide both sides by a variable or I lose a solution. But I can divide both sides by a number, right? So if I divide each side by 2, what am I going to get on the left side? 8x equals negative 15. Okay. Now look, we've already got this now in the form x squared plus bx. So I'm going to ask you 2 different questions. So be prepared to answer both of these. I want to know 2 things. I want to know, first of all, what's the number I'm going to add to both sides, and then I want to know what's on the left side, when I do that, what is going to be the perfect square that we get? In other words, what's the magic number that's going to occur twice? Let's answer these out of order. What's going to go there? Negative 4, right? Everybody agree? That's going to be negative 4 because it's always going to be half of b. Okay, but to make that happen, what magic number did I have to add, or excuse me, what number did I have to add to both sides? 16. I had to add half of 4, or half of b, which is negative 4, squared. Right? You see how that works? And then, on the left side, now what are the magic numbers that multiply to 16 and add to negative 8? Negative 4 and negative 4, right? Okay? On the other side, what do I get? 1. Okay. And then, so if we want to solve this thing, that's pretty easy, right? What do we do to solve this thing? Square root both sides. So I get x minus 4 equals what? Well, no. Okay, plus or minus though, right? Remember, when I square root both sides, if I'm doing this, then that means I have to include a plus or minus. Okay, last step. Add 4. Okay, and remember, I'm going to add 4 in front of the plus or minus then, right? So I'm going to get x equals 4 plus or minus 1. Do I leave it like that? No. I can simplify both of those. If I take the plus case, what do I get? 5. If I take the minus, 3. Those are my 2 answers, 5 and 3. Okay? But isn't it easier to write it this way, though, as some number plus or minus some other number? Yeah. Okay? Rather than doing plus or minus 1 plus 4. I know that in Moodle, I think it does those backwards, doesn't it? I'm pretty sure it does them backwards. I don't know why. That's just the way the computer algebra system, the brain in Moodle, simplifies that. But don't do it that way. You know, we want to do it this way instead when you're checking your answers. Okay, how about this one? This is a little tougher. Somebody different here. What are we going to do? What's the first step going to be? Okay, I got to divide by 4, don't I? Because I need to get x squared plus bx on the working side, right, with the x's. So if I divide each side through by 4, what am I going to get over on the left side? Negative 3/4, okay? All right, so 2 things then. What's going to be the number that I add to both sides? 1, because it's going to be half of negative 2 squared. So just negative 1 squared, right? Which is 1. So I'm going to add 1 to both sides, which means what's going to be the factor on the left side? What squared? X minus 1, right? Yeah. Okay. And on the right side, what's negative 3/4 plus 1? There you go. Okay. Square root both sides. What do I get? Plus or minus. Good. And the square root of 1/4 is just the square root of 1 over the square root of 4. So 1/2, right? And then last step.
You gotta add 1.
So I'll just add 1 to both sides, so I get 1 plus or minus 1/2. 3 halves or 1/2, right? Okay. All right, so then if you wanted, this is what's on your sheet. Yeah, I prefer you don't even, I don't really like this stuff. I don't really like when you get like a list of steps, right? A list of steps implies that you gotta memorize this thing. You memorize it, you're gonna forget. That's not good. When you know how to do this, you know how to think about this in terms of a strategy, right? You understand what you're doing when you complete the square. All we were doing was trying to create the conditions to build a perfect square trinomial on one side so that I could isolate x, right? I mean, if you want to review the steps, well, here they are, right? But you don't have to think about it as steps 1 through 6, because you're just gonna forget something like that. But I mean, so let's make sure these make sense. So what are we doing here first? Well, we're writing it as, we're gonna push the constant to the other side, right? So we get ax squared plus bx on the left side equals some number. We divide both sides by a, so we get x squared plus, call it b, it's not the same b, is it? But we just get x squared plus some number times x equals some number. Is that the same c as that one? No, it's not. C just stands for some number, right? So once we get it in that form, then we complete the square, right? We're gonna add half of b squared to both sides, we're gonna factor it, and then we just isolate x. That's all that's saying. Okay? All right, so let's try one more of these things. One more. So why doesn't everybody take a second on your scratch paper and get out your notebooks and just try doing one of these. Then we'll go through this together. Take a minute or two and we'll talk about it. This is just number 6 on your notes too, so if you want to do the work on there, that's fine. So let me ask you something. Are you enjoying doing this one by completing the square? It's not. It doesn't fit it very well, does it? Right? I mean, like, this is. These were pretty easy to complete the square, weren't they? You see if you can see what the difference is. Like, that was really easy to solve by completing the square. Very quick, right? That one was really quick to do by completing the square. That one, not bad. We did get a fraction in there, right? But it wasn't horrible. Like, I would give these maybe thumbs up for completing the square. That one's kind of a thumb sideways maybe. This one, I would give this a firm thumbs down on completing a square. Now let's do it, but then the good news is, I'm gonna make you do a couple of these on this assignment, just so you can really practice, over practice the process. But eventually we're getting to a point soon in this unit where we're gonna have a total of 4 different methods for solving quadratics, and our job is gonna be, we gotta find the easiest one based on the kind of problem we're looking at. Do you think this is one we're eventually gonna do by completing the square? No, there's gonna be a better way. It's never gonna be just a super simple one to do, but we could make it simpler by using a different technique, using a different strategy. And we'll get to a point where we'll be able to look at this and you guys will be able to tell me, okay, that's when we want to complete the square. That's when we want to factor on. That's when we want to do our fourth, we haven't talked about yet, our fourth option, okay? So let's go through it real quick. What are the steps going to be? What do we got to do first? Got to subtract 8. Good. So step 1, we're going to get 3x squared plus 10x equals -8. Now what? Divide by 3. That's unfortunate, isn't it? That makes things tough. Dividing by 3 does not help things. I get x squared plus 10/3 x equals -8/3. Okay. So what's the number I got to add to both sides? Half of 10/3 squared. So what's half of 10/3? Well, it'd be 10/6, which is 5/3, right? So half of 10/3 is 5/3. Squared is 25/9. So I've got to do, right? I've got 5/3 squared, which is 25/9. I've got to add to both sides. Now, what's that going to do to the left side then? What's my perfect square factor going to be? X plus 5/3, whatever that number in there was, right? Half of b squared equals, so see if you can do this in your head. What's -8/3 plus 25/9? 1/9. Yeah, because I'm going to multiply, very good, I'm going to multiply this one by 3/3 to get 9ths on the bottom, right? So I'm going to get -24/9 plus 25/9 is 1/9. Okay, square root both sides, right? And then what? X plus 5/3 equals what? Plus or minus 1/3. Last step? Subtract 5/3, and I'm just going to put that right there. So I get -5/3 plus or minus 1/3. So if I take the plus, what do I get? What's -5/3 plus 1/3? Okay. If I take the minus, -5/3 minus 1/3, -6/3, which is -2. Those would be my two solutions. Okay. All right. So then, see if we can come up. I mean, that worked. I guess that wasn't quite as bad as we thought it was going to be, but it could have been worse, right? It could have been worse. What if, when we took the square root on this side, easily, what if that hadn't been a 1/9? What if that had been like a 1/12 or something? And then I get radicals in my answer, and then it starts to look more ugly, right? So let's see if we can come up with a better method. And this is something, I think this is a really important thing for us to go through together. In fact, I think I'm going to make you guys prove this on your own. I mean, I'll go through it with you, but then I want you to demonstrate that you can go through this proof too. Okay? I'm not sure how I'm going to do that yet, but I'm either on paper or I might do it on an equation editor on Moodle or something like that. But this is a really important process. So what if we want to come up with some way we can do this all the time? We want to come up with a formula for solving a quadratic equation in standard form. So if I've got something in the form ax squared plus bx plus c equals 0, so if I set it equal to 0, could I come up with a formula that's always going to give me the solutions? Now you probably know what the formula is. No? It's the quadratic formula, isn't it? But how do we come up with that? The way we can do this, how do we build a formula in math? The way we build a formula in math or in physics or anywhere is we're going to start with an absolutely general equation. We're not going to specify anything. We're going to just, instead of putting numbers in, oh, hang on one sec. This could be important. Hang on. So we haven't specified what A, B, and C are going to be, right? It could be anything. We could plug any numbers in there, which means it could be any conceivable quadratic equation. We're going to solve this in terms of a's and b's and c's. So when we solve for x, then what should we expect to get in our answer? A's and b's and c's, right? Doesn't that make sense? Because by changing these numbers around, wouldn't we expect that to have some impact on the solutions that we get?
Yeah.
Okay, so that's what it means to create a formula. We're going to solve an equation from an absolutely general state where nothing's been specified. This is just could be any quadratic equation in standard form. All right, so how are we going to do this? What's the only way at this point that we know how to solve an equation like that, a quadratic equation in standard form? Yeah, it'd have to be. We can't factor it, right? Because we'll never find magic numbers because we don't know what the numbers are. So we can't factor it, but we could complete the square. We could go through that process we just went through, only we don't have numbers, we just have parameters that stand for numbers. Okay, so what would the steps be then? Let's just go through these together. What would the steps be to complete the square? First, I'd have to subtract c, right? I got to get the x squared and the x term by themselves. So step one, would be we just get ax squared plus bx equals negative c. Okay, now what? Divide by a, because I need the left side to be x squared plus some number times x, right? So if I divide both sides through by a, what am I going to get? X squared. Oops, back up. Plus b over a times x. I could do bx over a, but that's the same thing as b over a times x, right? Because a and b are just numbers. Everybody agree? On the other side, we're going to get negative c over a. Okay, so now to complete the square, I've got to add to both sides the right number to create a perfect square trinomial, right? And I'm going to put it out in front this time. Instead of putting it here, I'm going to put it out in front. So what's that going to be? Half of b divided by a. Well, what is that? If I do b over a, half of that, I'm not going to divide by 2. I'm going to multiply by 1/2, right? So I just get 1/2 times b over a. If I multiply straight across is b over 2a. Everybody agree? So that's what I'm going to have to square. B over 2a squared. Well, if I square a fraction, I square the top and I square the bottom. So what's the top squared? And if I square 2a, the quantity 2a, what am I going to get? 4a squared. Okay. Okay, everybody agree? So then that's, the left side's actually going to work out fine then. We know what we're going to get for our magic numbers. They're just going to be b over 2a and b over 2a, right? Okay, so on the left side, I'm going to get x plus b over 2a, quantity squared, and that's just the number from right there, equals, what about over here? Well, let's get a common denominator and add these up, just so we can make it a single fraction. So what would I have to multiply this fraction by to get a common denominator? Top and bottom. Let's see, I got to get a 4a squared on the bottom.
So just
4a, right? Everybody agree if I multiply both the top and the bottom by 4a, then on the bottom I'm going to get 4a squared and 4a squared. That's an a, right? So then that's going to give me my common denominator of 4a squared, and on the top I'm going to get a b squared minus c times 4a. Well, I'm going to write that as 4ac. Okay? Stay with me? Okay? All right, now what?
then you square root.
I'm going to square root. Okay, I'm going to square root both sides. Okay, so the next step, I guess that was step 3. Step 4 would be if I square root both sides, I get x plus b over 2a equals what?
B
plus or minus, and then I'm gonna have to square root the whole thing, right? So I'm gonna get, let's see what happens. A little side box here. If I square root b squared minus 4ac over 4a squared, that's the same thing as square rooting the top and square rooting the bottom, right? So on the top, I'm just stuck with the square root of b squared minus 4ac. But on the bottom, 4a squared, I could write as what? The quantity 2a squared. And what's the square root of something squared? Ah, it cancels, doesn't it, right? So on the bottom, I'm getting a 2a. Looking pretty good, isn't it? Last step, subtract b over 2a, right? And so finally I end up getting, after 5 steps, I get x by itself. I'm putting my negative b over 2a right there. Negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. But what do you notice about the denominator? Common denominator, right? So we could just simplify and write that as x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What do you know? Okay, so now that's pretty cool. Think what we just did. I mean, we just came up with something that looks somewhat complicated, but it's just got a's and b's and c's in it. I solved for x, and I got 2 solutions, one for the plus and one for the minus, and all I've got to do now is plug in whatever a, b, and c were, the coefficients in my quadratic equation, right? That's amazing that we were able to do that. It's amazing. It is kind of amazing. So when are we out of here? 2:10? Okay, so in order, have I showed you guys the little, have you guys heard my little song yet? Quadratic formula song? Okay.
It better be the right one. It has to be the right one, because all these